I think with that, we are all ready to get started. So, like I said, I'm super excited for this topic, and we have my colleague Dr. Shantanu Tuli here today. She's a data scientist at Astronomer and has a lot of great experience in this area in productionizing machine learning workflows. So, super lucky to have her share her insights on this topic. And with that, Shantanu, I will hand it off to you.
Thank you so much, Kenton. Hi, everyone. I'm Shantana. As Kenton mentioned, I am sitting outside, so you might hear birds. You might also hear the traffic, and my internet might be a little bit wonky, so just bear with me. My name is Shantana Tuli, and I am here today to talk to you about machine learning, specifically in production, and where Airflow fits into that story. So, the age-old wisdom now is that machine learning replaces this classical programming paradigm where we used to take rules and data and get the answers from those rules and data. And whereas now we can sort of invert it and start with the answers, known answers, and the data, and then discover the rules. We can then use those rules to go from any new data to predicted answers. So in a nutshell, that is what machine learning is, right? And regardless of how machine learning works, and the rules are actually just transformations on the data. So regardless of how machine learning actually works, the bottom line is that the machine learning applications are use case driven, and they produce some value for whatever entity, be it a business or an academic study, whatnot. So then, in sort of more recent years, certainly we're asking about what is machine learning operations as we try to operationalize our machine learning application software, just like any other software. It becomes important to define what that exactly means, machine learning operations. And to me, it just boils down to this one thing. It's getting our machine learning algorithm that already solves some sort of business need to deliver its value at scale. So the distinctions between machine learning and machine learning ops, I like this diagram as a way of sort of visualizing it. The thing is, machine learning is often a process that's repeated, right? We're sort of, it's usually something where data comes in and you sort of figure out what the trends are in the data, and the new data comes in, and then you want to make predictions on that data. So there is a cyclical nature to this, a repeated process. And then the thing about machine learning is also that it is after development, partly because we really need to understand the data. We need to figure out what's going on, and that means experimentation. Have a model that's doing what we need it to do, providing the value that we start thinking about how to productionize this. So to get the machine learning application to produce its value sustainably, we need to build the service or platform that's actually going to host the model, right? We need to orchestrate the steps. In this model, we need to set up learning on behavior against thresholds. I'm sorry about the background noise again. We need to deploy this model, so packaging it up and deploy it so that it's actually available to end users who can, get value out of this model. So, for example, if we have a recommendation engine of some sort that is serving up something on a website, then we actually have to make sure that the model gets there, so that when someone comes onto the website, they get their set of personalized recommendations. Sorry, there's a question here. No, it's not your internet. It is more likely my internet. I will try to go a little bit slower, and please just interrupt me, Kenton, if I need to sort of stop. So yeah, all of these considerations, and of course there are additional ones like, how do we, and this is where we start thinking more about traditional software releases, right? How do we roll out updates, how do we roll back when something goes wrong? We need to set up logging, and we need to see how the trend evolves because it's repeated, how different trends evolve over time. So visualizing that can become important. And then as an additional step, we need to allow for changes to the model, such as hyperparameter optimization. Perhaps we need to do active learning or transfer learning using our model. So all of these things together is, planning how to do each of these steps is what gets us to have our ML model produce its value sustainably and at scale. So what does a machine learning workflow often look like? We start with that experimentation and development. Then we start to operationalize. Orchestration is a part of that operationalization. And then it all sort of feeds back and it becomes an iterative process. In that machine learning development, we have to think about data featureization, actually modeling the data and how we sort of evaluate the performance of our model. In the operationalization section, that's where we're thinking about that architecture and scaling and really the system that's going to host the model, its reliability, etc. And then orchestration, the reason what you highlighted separately is it's one of the biggest chunks of that operationalization piece. So this is where we think about what cadence the model's gonna run on, how we're going to set up versioning, how we're doing the serving, how we're monitoring our data and our model, trying to catch any drifts, and how we are thinking about being able to govern our model in production. So if we break down the steps that take us, the steps involved in developing a machine learning application, we start with clarifying the business requirements. Again, at the end of the day, the machine learning model has to provide some value. So it's usually driven by some sort of requirements, right? That's where, but not just what is this model going to do, like what is its purpose, but also how available does it need to be? So defining the SLAs and SLOs, right? How effective it needs to be, what are the acceptable ranges of its performance, like precision and recall. And then to what degree do the steps need to be automated? These are some examples of the things that we want to clarify sort of towards the front end of this. And next we assess the available data. Perhaps we connect traditional data sources, gather the data. Then we're actually working on developing this pipeline. And of course, this is, it's not to scale. So, this part usually takes the longest. And then we deploy the model. And finally, we're not done after deploying our model, but this is where sort of we have to maintain the model operations. So we have to make sure that it's auditable, that the whole cycle is reproducible, right? And that's where versioning comes in. It's extremely important also to have our machine learning models be explainable, at least in terms of tracing back a predicted output to the sort of the contribution, the things that contributed to that output. So if we think of this as the life cycle of developing an application, how do we actually achieve it? Well, there are many different ways in which it's currently being achieved by different teams at various institutions, and there isn't really a standard. We're working towards a standard, obviously, but there are different ways of doing this, and they're all valid, right? It's all about your needs and what standards you have to meet, and etc. So one approach is productionized notebooks. This is, for example, a Databricks notebook that's orchestrated. You can use Papermill with Jupyter. SageMaker offers notebook, architecture. And then sort of often the orchestration element will also be provided by the software, and if not, you can always pull in Airflow to do the orchestration, but it sort of takes care of some of the versioning and other aspects of MLOps. Then there are the MLOps platforms, which MLOps is in quotes, not because it's sarcastic, but because it's it's an ill-defined term, right? If you go through this list of all of these tools and you start researching each of them, you'll find that no two of them offer the same set of functionalities. So it's and often some of these need to be strung together in order to achieve a more comprehensive MLOps, architecture. But yeah, so this is where you have platforms or managed platforms or more end-to-end platforms where you can sort of start with essentially, raw data, and it'll do some of your featureization for you. There's some hyperparameter optimization that some AutoML offerings will do for you, and then all the way through to where is my model, where's my model deployed, how is it deployed, sort of packaging that up, and then serving it and monitoring it as well. So that this is another way of doing machine learning operations. And then thirdly, you can just write your custom pipelines, right? Maybe most of your steps can be written, usually it can be written in sort of lower level code, and then you tie it together. You do your own versioning through Git. You do your CI/CD through various CI/CD applications, and then you do the orchestration with a tool such as Airflow. Now, the cool thing about all of these different approaches to machine learning in production is that you can actually leverage Airflow for all of them, right? Because orchestration as a component of operationalization is done really well by Airflow, and not always offered by these tools, or not offered the same level of reliability. So you can bring in Airflow and wrap your Databricks jobs, your Jupyter notebooks. You can use it. You can use Airflow with Kubeflow, Azure ML, and we have many example DAGs, Airflow DAGs out there on the registry for you, where we do that, and you can see different ways of different pipelines to build using Airflow and some of these tools. And obviously, if you're writing custom pipelines, you can just write your MLOps pipeline in pure Airflow, pure Python, and sort of orchestrate it like so. Okay, so this is again sort of going into the different steps. So typical end-to-end machine learning pipelines, sort of going a level deeper than than we were before. So we start with data ingestion. That's usually falls on data engineering. Then there's the data exploration, feature engineering, model building, and this is the more experimental phase, which usually falls in data science. Once a model is built, we move on to the ML operations aspect, where the model is trained, retrained, deployed and served, and monitored. And at each of these stages, we're gonna work with our business counterparts to define the requirements and make sure that our product is actually adding value to our users. Once we have sort of settled on a model and feature architecture, right, then we usually go from ingestion all the way, and just the featureization becomes this step, and then you go to model training, as opposed to doing the exploration and feature engineering. And again, this entire pipeline, there are so many different tools that can fit into sort of orchestrating these steps. Now, which parts of these steps are actually automatable? As we said, the exploration experimentation phase of this journey is usually not automatable. However, the rest of it is, right? Going from your ETL pipelines, data ingestion, to model training, deployment, serving, and monitoring, all of these can be automated. In fact, we can use that the monitoring to trigger on, circling back into the data science phase, just as a way of alerting, hey, this is going on, model's not doing so well. Let's re-enter this phase of feature engineering and model optimization. Okay, so this is what then the automated production pipeline looks like. We've got ingestion, featureization, and then model training, deployment, and monitoring. And we can do all of these steps with Airflow. So we'll go into why Airflow real quick, and then we'll talk about different sort of architectures, and we'll actually build a model and see how that works. So Airflow, because it's Python native, and that's sort of become the language of data scientists and ML engineers, and it is a really good common interface between these teams. So like we said, there's the data engineering involvement, the data science involvement, and the machine learning engineering, as well as machine learning operations involvement. And it's one of those tools that is really, can span all of those functions, and you can work in Airflow for your pipelines. You're often working using Airflow to write ETL. So this is just an extension of that, if you think of it that way. The biggest strength, I think, for me is that Airflow integrates with just a massive number of other tools easily, right? So data sources, obviously all Python libraries, tools like TensorFlow, SageMaker, MLflow, Spark, et cetera, et cetera. Any tool that you can think of as part of the stack today for data and machine learning, Airflow is going to integrate with it. And if it doesn't, let us know. We'll make it happen. Monitoring and alerting is a big one. Airflow has great features for logging, as well as alerting to external systems, like getting emails and Slack notifications, right? It's extensible. So you can write your custom operators. If you're finding that you're doing something over and over again as part of your ML pipeline, you can turn it into your own operator. And that works really well. And then the last three are also super powerful points. Pluggable compute, you can basically Airflow will scale or help you scale your infrastructure however you need it to. So it's elastic in that sense, which is very powerful. It's data aware, so you can definitely pass around data as a first-class citizen, but it's also data agnostic, so it doesn't actually care about what your data is, as long as the tasks can communicate with each other and agree on the input and outputs. And then finally, it's cloud native, but cloud neutral. So whatever your cloud stack is, works well. So orchestrated with Airflow, then the automated parts kind of look like this, right? You can, Airflow comes in at every stage of these. So you could write these as separate DAGs that are sort of have some loose dependency, or you can roll it up into a DAG. You can pass metadata between tasks, right? So what is maybe whether or not I want to do some sort of validation check depends on whether or not a new model has been deployed, right? So the latest model ID, you can pass between tasks and use to see, oh yeah, there's a new model now. Let's sort of re-trigger my CI/CD or model validation on that new model, so on and so forth. And of course, you can also pass data itself. So as far as how Airflow sort of plays or orchestrates the pipeline, you have options. So you can schedule different components of this. You can set the sort of dependencies using sensors, or you can directly, use one part to trigger another part. So, I'll go through an example of a pipeline that I wrote, but I really prefer to think of it as like separate parts. So I'll usually do a training DAG and sort of a deployment DAG, or perhaps a sort of validation DAG and then a deployment DAG, and then a predict DAG. So, really however you want to set those dependencies and relationships between each other, you can. So yeah, as I said, in addition to metadata, of course, you actually pass data between these steps by leveraging Airflow. And at the end of the day, what that allows you to do is treat your data and your models as versioned products. We're hearing a lot around, data products as like a term. And what that really means is that you do the due diligence to the data and the models that you would do to any other product. And Airflow really helps you do that through these orchestration ops pipelines. Okay, so let's look at a specific model. So this is going to be on the Apache Airflow GitHub repo, data. So there are about 22,000 issues now in this GitHub project, and they comprise enhancement requests as well as bug fixes, and the contributors to the project have to triage any new issues that are coming in on a regular basis. So on a weekly basis, about hundreds of new issues will come in on average. So you can imagine ahead of big releases and stuff, it's a lot more. So it's the incoming data is very interesting, and it's something that you have to a human being has to triage in order to figure out what the importance is of issues, a relative priority, etc. So that's the input. What's the output? So for this model, the output is a web application that predicts when a new issue is going to be resolved, right? So an issue comes in and we make a prediction on how long it will take to actually resolve the issue. So we've turned it into a classification problem. Is it going to take hours, possibly? Is it going to be on the order of days, or is it going to be on the order of weeks or months? Because some issues do stick around for a bit longer, depending on just back and forth. Cool. So Airflow. So like I said, split it into a training DAG, first of all, which once a day retrieves all the issues and their current state, whether they're open right now or closed, every day from the repo. So the same issue, of course, will have open state, and then it'll change to close at some point. So the data is pulled completely every day. It then featureizes these issues and assigns labels, which is, for using the closed issues, how long did it actually take for those issues to get trained? And then it trains a gradient boosted classifier, a light GBM model in this case. So this is what the DAG looks like. Very simple to look at. Get issues, featureize, and train model. You can see that I've used the Python decorator. So we'll look at the code here in a sec, but I'm a huge fan of the Python the decorators task flow API. And then the other things to point out here is we're doing this where the scheduling shows up. So you've got the schedule, you see it right in the DAG view. You can see what kind of what state the tasks are in. And you can also see, the list of operators that are in use. Okay, so let's hop out here to take a look at the, so let me stop share and reshare, just my code editor. Are there any like pressing questions that I should address now, Kenton?
Shantanu, one that's relevant is somebody asked if you could expand a bit on how versioning works for data products.
Sure. Yeah. I'll get into that in a little bit here. So this is my training DAG, right? So it's quite simple. Partly because I like to keep my DAG files sort of cleaner, and so obviously we have the bulk of the code or the functions that are doing the processing and stuff I'm pulling them in from other packages, right? So I've defined a bunch of steps in getting issues and featureizing the issues and then training the model. And then as far as the other imports goes from Airflow, I care about the DAG and task decorators, and I use S3 here for my going back to versioning and storage. So for all my stores, in this case, model store, feature store, I do a target store as well, because I want to see how things change over time. And then a model store as well, which we're going to take a look at. And then other than that, it's your usual imports in your data stack. So everyone is probably familiar with all of these packages. So what I'm doing is using an S3 hook. So that's just the hook connection. I'm creating a bucket on S3 side, and then I'm ready to go to create to define the path to my S3 bucket, or the sub portion of my S3 bucket, and that's a choice that I've made for versioning in this case, right? It's a daily date stamp. Okay, so this is so I've got two functions up here that are around just uploading to S3. So I give the path to the S3 location and what is actually to be saved, and I'm using the S3 hook to actually push the file up to S3 in the appropriate store. Then I have a similar function that retrieves cached data from S3 because I want to be able to, pull things back and then work with them. So specifically what that looks like is in my get issues function. So this is my DAG definition. I've got it running daily. I've got start time specified, and I don't need the catch up to be true in this case. It's a very simple, elegant way of just, defining what the DAG needs to be. And then my first task here is getting issues. So I am, again, pinging my get issues for training package and getting the get issues for training method from there. And if I successfully retrieve those, then I push the new set of issues into a cache location. If I, so in the next task, what I'm doing is I'm featurizing the issues, and I first start with saying, hey, do I have cached issues from? And if that doesn't exist, then I will go ahead and use a previously cached versioned data set. So this is one of the things that we do for ML pipelines, because let's say something goes wrong in the data ingestion. So today my ingest task fails, right? Which is the get issues task. It fails for some reason. I'm going to go ahead and debug that, and Airflow, the Airflow UI is going to show me that it failed, and give me helpful logs to see why it failed. But in the meantime, I don't want the rest of my pipeline to stop working. So this sort of fallback protocol, very easy to define within the scope of Airflow. Okay, so either way, I have a set of issues, and I'm doing my training, and then so what I'm doing here is saving uploading each of those things outputted from the training step into its own store. So what I'm getting back from featureized training issues is a set of features based on those training issues, set of feature holdouts, target holdouts. Then one of my important features in the data is whether the person who created the issue is someone who frequently creates issues. So I keep track of that. I keep track of the labels that are important, that are getting used the most in the repo at this point in time. And these end up being additional features in my model as well. And I do vectorization of the title and the body of the issue because they're written in natural language for the most part. So those things I also save as pickles, depending on the format. So I save my feather and target as my features and target as feathers, and I have a lot of control over what format I want to save the data in, and then I push it up to and the respective S3 locations, again, time stamped with today's date. The returns from this featureized task are, it's going to do all of these pushing out to the feature stores or blank stores, but it's all going to return the features and the targets for the issues that it was able to grab for today. And that's what my train model task actually takes, are the features and issues. So in this case, so we're obviously we've deployed the model already. So at this stage, it's retraining the model. So retrain model takes these features and targets, and then uses that same S3 hook to push back that trained model in a pickled format. So now my model lives in an S3 bucket, trained and ready to make predictions. In order to tell the DAG what the dependencies are using this task flow API format, right? All I have to do is say featureize takes get issues as its argument, and then the trained model takes featureized features and featureized target. And then that's it. Train equals train DAG. So that's sort of one of the DAGs that, oh, let me share my slides again. Cool. So that was my training DAG. The next thing that I'm interested in doing is deploying the model, right? So this DAG runs every 15 minutes. And again, these time schedules or orchestration intervals are going to depend on what your actual needs are. In this case, I don't need it to be any sooner than that. So every 15 minutes, I check for a new model. And if I do find a model, so this here, the first task, check for a trained model, is an S3 key sensor operator. So I'm using a sensor to see, oh, is there a new tagged model in my S3 bucket? If so, then it'll go ahead and validate the model. And based on whether or not the validation check passes, it's going to choose the deployment strategy, which in this case is either you deploy the new model or you just fall back to the old model. So during this specific DAG run, right, the deployment requirements were successful. So we went ahead and deploy the model. And that's why the fallback is in skipped state, because that we didn't go in that direction. So this here, the choose deployment strategy, is a branch Python operator. So here you can see we're using other operators and sensors in addition to my task flow decorated operator, and it blends nicely together. It's not like you're tied to using task flow just because you're using task flow. You can definitely hop back and forth between the two. Not sure if I pointed out anything. Okay, yes, sensor and branching, which I already talked about, at the skipped path. All right, and then last but not the least, of course, is the prediction DAG. This is the DAG that's going to predict on new issues as they come in and try to determine how long it'll take for the issue to get resolved. So this one actually runs every 2 minutes because, we don't want an issue that's created to be sitting for too long without getting a prediction. So what it does every 2 minutes is it retrieves new issues, featureizes them, and then it runs the deployed classifier model on these issues to predict the time to resolution. So get issues, featureize the new issues, predict, and then serve the predictions into that web app that I showed earlier. Again, another super simple, straightforward, linear DAG. It does what it needs to do. So, didn't introduce any additional complexity for the sake of complexity. Cool. So, because we're doing that validation on a regular cadence, right? Every time there's a new model I'm validating it, I can do the model performance tracking. And the front end here was relatively simple to spin up. I mean, it's kind of not as necessarily always tied to the model development lifecycle, but tools like Fast API do make it super easy to spin up front ends. So this is, just a visualization of how the classification actually went. And if I am a data scientist who is responsible for this model, I don't really need to go and dig super deep into my code or even in my Airflow deployment unless things go wrong, right? What I would like to do though is be able to see, oh, how did my model actually do? Is it reliable today? Okay, I mean the threshold was successful. This threshold check was successful, so I know it's good, but how good is it? And just to look at more specific numbers rather than just getting a checkbox. I can also obviously do feature study and interpreting that model. So that's up here as well. You can see that the length of the title and the length of the body are big indicators of how soon an issue will be closed. Cool. So altogether, the train DAG, the deploy DAG, and that predict DAG make this come together to make this pipeline: the data ingestion, data featureization, model retraining, deployment and serving, and monitoring. And so altogether, what we've seen here is an end-to-end ML pipeline that is orchestrated in Airflow by Airflow. But that's just one example, and it's one where Airflow does most of the heavy lifting, right? We leverage other technologies like AWS, specifically S3, and we use LightGBM as a model, and we use Fast API for the front end. But overall, it's orchestrated by Airflow. It's a major part. But we've seen lots of other architectures as well where Airflow does play a part in the whole gambit, but it also integrates nicely with individual tools that fill in the individual steps, right? So here's an example of a feature engineering DAG here. These examples that we've seen have been through user research and talking to teams across the board on how they're doing, how they're leveraging Airflow for machine learning pipelines. So these are actual DAGs and architectures that are being used today to drive value at various companies. So in this DAG, we check for new files using that S3 key sensor, not unlike the one I just showed. We're reading and cleaning the data using our usual packages. We're using the Python operator. We're using pandas and scikit-learn, and just Python. We're generating our features using a Kubernetes pod operator. So we're leveraging Kubernetes as a technology for feature generation, and then we're writing the features to a feature store, in this case in Feast. So if we're using a custom Feast operator because this team needed some sort of customization, so they wrote it. And then similarly, we write the data after that cleaning and transformations. We write it back to the data warehouse, or we write it to the data warehouse using the Snowflake operator, so that in addition to perhaps model training, it can be used by human end users for other purposes as well. Here's another one. This is a machine learning operations DAG. So we're starting with, we trigger from the data engineering DAG based on whether or not there have been significant changes to the data. So if the data changes now, or if the underlying data changes significantly, then I have a vested interest in training a new instance of the model so that I'm not losing, that freshness of the model. So based on that trigger, we start training a new model. Here we leverage TensorFlow, MLflow, and the Kubernetes pod operator for doing so. Once we have a trained model, we save it to a registry in MLflow, and then we simultaneously deploy the model to production, in this case as a Bento ML image, again leveraging the Kubernetes pod operator, and then we update the model monitor, which is happening in this case in Fiddler AI. So all these tools, of course, are popular and they offer really, really strong functionalities. But at the end of the day, they're all being tied together by Airflow. So again, here the loop back is if I have significant model drift relative to the previous model because of whatever the significant changes to the data were, then I know that I have to sort of loop back and possibly train a new model or rethink the architecture and whatnot. Here's one where we're doing feature generation and model training. So again, raw files, and because we're cloud, we will work with whatever cloud we've seen. We were seeing S3 here. Now we're looking at GCR. In this framework, we're using GCS. Let me do a quick time check. Okay, I'll wrap here in a little bit. And then we are doing transformations in BigQuery, TensorFlow again with the cube operator. And we can send out notifications in Slack, email, etc., based on whether our transformations were successful or whatever have you. And in this case, we're storing the model back into an S3 bucket. So you can see here a multi-cloud sort of architecture, and Airflow just spans all of it. You're not tied to a specific cloud offering or anything like that. This is a model management one. This is super intricate and cool. So we read features, I believe, read extracts from BigQuery when we read in the model. So this is sort of after I have a trained model and I'm sort of deploying the model. So I read the model and the features. I deploy the model in SageMaker, which itself is an MLOps, strong, powerful MLOps tool. And then we write the results using Python operators to BigQuery, and we do the metrics check in a Python operator, write it also to BigQuery, and send notifications as needed. Here's one where this particular architecture maintains hundreds of models across product recommendations, churn prediction, and fraud and anomaly detection in a company that's in the finance domain. And here you can see leveraging Snowflake, S3, H2O, AI, another strong MLOps tool, and AWS EMR, and then SageMaker at the end, and just tying together the ingestion, feature engineering, and model training and serving all together. And then finally, if you have legacy systems, sometimes those can be a little tricky to sort of integrate with the more modern stack, right? But Airflow is, again, really because it doesn't care what the stack is, it'll just integrate with different components, right? So it's easy to bring everything together in the same platform using Airflow. So of course, there are lots of considerations when we are operationalizing our machine learning applications, such as containerization. We think about whether we want it on the cloud or on-prem. What sort of compute resources do I need? Is it, at the end of the day, is it a batch operation or a real-time operation? And all of these things will help us, and all of these considerations will sort of help us make the right choices as we sort of think about the architecture and of how to deploy our model and like have it maintain at scale. And at every stage, depending on the choice, we're going to like the different choices within Airflow. And then for the monitoring elements, when we talk about MLOps, we have to talk about testing, versioning, performance, and stability, which the monitoring will help alert us against, the various system level metrics, all of which we would want to track, and then governance, and how do we do fallbacks, how do we do explainability. So just these two slides are to try to summarize what the considerations within MLOps are, so that when you go and build your MLOps pipeline in Airflow, sort of some of the things to think about. And that's basically all I had. The message is that machine learning applications have so many different components and incorporate and result from so many different use cases. There are a large number of tools out there. They incorporate lots of different teams that have to work cross-functionally. And at the end of the day, having a framework, a orchestration framework, or just something that sort of glues all of that together I've found it to be extremely powerful and useful. And that's sort of what I see Airflow as. Thank you.
Awesome. That was great, Shantana. So much good information in there. As you said, I think this is a really big topic. So sure, lots of people really appreciate having a great overview there. We do have a couple of questions that haven't been answered yet in the chat. So we will go through those, and I'll say to everybody else listening, if you have questions, again, we do have a few minutes left, so we will answer those. Please throw them in the Q&A. So we have a couple of questions actually related to sort of the tools and the ecosystem and how all of that fits together. One is, Can you speak a little bit to how this might work with Databricks? So if you were, integrating a workflow where you might have Databricks SQL as the data source, or using Databricks as machine learning kind of tools for featurization or things like that. Have you seen examples of that, working, and where does Airflow fit in there?
Yeah, absolutely. And I mean, not only have I seen examples, but I've written. So in my past employment, that's what I was doing. Is our machine learning code algorithms lived in Databricks notebooks, and we're leveraging Spark clusters to do our compute, right? But we were orchestrating the pipelines using Airflow. So Airflow was the glue that spoke to Databricks, and we were using, again, AWS S3 as our feature store. And it was sort of the thing that like brought it all together. More specifically, what it looks like is a colleague and I, Amira and I, did a webinar last month, or maybe the month before, where we sort of showed how to connect Airflow to Databricks. So I won't go over that again, but it's quite simple, especially on the Airflow side. You generate a token from Databricks, you put it in, as connection variables within Airflow, and now you are able to submit Databricks jobs. You are able to spin up clusters in Databricks from Airflow. So if you have parameters that you want to send, Databricks has this thing called DB utils, which allows you to parameterize notebooks and send in those parameters. So let's say if you have maybe 15 different model or versions of a model, per client or something like that, or maybe 150. And for each of those, you want to configure a separate set of configurations for running the models. You can send that from Airflow into Databricks and trigger parallel DAGs on using those Databricks notebooks, and it just runs smoothly. So we'll have more content out too. I mean, there are already Databricks Airflow sort of example DAGs on the website, but that's something that we're also producing more on.
Awesome. And a related question on versioning, since you just mentioned that, how do you maintain model versioning within Airflow? Or how do you deal with versioning across both feature stores and models?
So it's less within Airflow and more powered by Airflow, right? So because Airflow is the orchestrator here, and we're running, we can attach sort of that timestamp of running. We can attach, each DAG run and each task run in Airflow gets its own tag, its own version tag, right? So you have this line that you can draw between the version of the code, the various settings that you have set, that including your environment variables, your resource provision, etc., all the way through to what the trained model looked like there, and potentially what the predicted values look like. So it's easy to draw that line across these different parts. I mean, I think that often we do sort of feature versioning, great, we've model versioning, great, but the code lineage is kind of lost because the code's sort of updating at different instances. But what I love about Airflow is that those DAG runs have those code sort of versions attached to them. And then I won't do a spiel on lineage, but that obviously is super important as well.
Yeah, for sure. We have another question on experimentation tools. So this was something that the pipeline that you walked through didn't have included in it. So question there is whether that was intentional and that's something that you would keep separate, or was it just not part of this example and that is something that you could include in a pipeline orchestrated by Airflow?
Yeah, that's a fantastic question. So the current landscape of ML ops tools, it sort of falls into those two buckets. One is around deployment and operations, and the other is around experimentation operations, right? So I see weights and biases, again, like a really, really strong tool, especially on the UX side. I've been really enjoyed playing with it. Is more on the experimentation front, right? And the thing about experimentation is that you often don't have to do it as often as you just have to retrain your model and deploy it to your end users. So really the tie there for me is that alerting. So I'm monitoring my model in production, and if something sort of falls below expectations or outside of expectations, right? Like I'm trying to catch any data drift, any model drift, that's when I will trigger based on that result, sort of an experimentation cycle. So yes, I could have had a separate DAG that would be like, let's trigger an experimentation. But as a data scientist, my opinion is that that's usually when a human being sort of has to come in and like take a look at things. And tools like weights and biases are fantastic for giving you all the information up front, right, as you run those experiments. But often sort of having it in the same flow as your operationalized workflow doesn't quite make sense.
Got it. Makes sense. And just, I think 2 more questions I think we should have time for in just the next minute or so. One of the example workflows you showed had a Docker image in it. And somebody asked a question on whether that Docker images is created automatically by MLflow, which was also in the pipeline, or by Airflow, or is that something that as a user you would customize and build yourself?
I'm not sure which workflow this is referring to. Of course, the astronomer packaged version of Airflow will I think maybe the question is, so the containerization aspect is obviously very important to an operationalized machine learning workflow, and for dependencies, for getting the right versions of packages, right, and making sure that like things run from instance to instance as they should, because nothing major has changed. It's sort of, I guess the way I see it, it's sort of nicely hidden away from the end user often. And then of course there's also the Kubernetes pod operator, right, where you're spinning up kube pods where you have more sort of control over what exactly is happening and how things are scaling. And honestly, Kenton, you're better poised to answer specific questions about Docker and Kubernetes. Yeah. I don't know if I answered the specific question. I don't think I quite understood it. So
yeah, so I missed the specific workflow, but I think you got it in general. I mean, Docker files, like a lot of tools, will have those sort of created at least with the starter bits that you need for you. So like the Astro CLI, if that's what you're using to run Airflow locally, will create a Docker file for you. But you can always customize those. And in the case of a machine learning workflow, you will probably have to, because you're going to be dealing with additional packages you need and, data stores and things like that. So hopefully that answers that question. One more that we've had regarding kind of the tools landscape is, can you comment on using Luigi or Argo for orchestration, specifically as regards to MLOps?
I personally cannot, other than saying that most of the teams that I speak to who are doing machine learning at scale today are using Airflow. Whether or not they're using astronomers, Airflow is separate. But as far as the industry standard around orchestrating your machine learning pipelines, it's Airflow. So, but we might have thought pieces around that. I'm not sure if we do, around benefits of one over the other.
Yeah, those aren't tools that I have seen used specifically for MLOps, at least in my experience. Like Argo, because it's so Kubernetes specific, is a little more limiting. So a lot of the reasons you talked about using Airflow, because it's designed to plug in very easily with tools like Databricks and sort of the full ecosystem, often tend to be better than ones that are highly specialized. Luigi isn't one that we hear about as frequently anymore. It was really big a few years ago, but I'm, to be totally honest, not quite sure of the state of the project. So this is an area where MLOps is something where you're definitely going to want to go with an orchestrator that is, being actively maintained, since MLOps is a new field, right? You're going to need a lot of the new features that are in development. So that is something I would look for when considering that. Great. Well, I think we are about at time. I know there were a couple of questions regarding future webinars on this topic or others. We will have more regarding ML orchestration and using Airflow for ML tools coming up. Mentioned a Databricks one. We'll have more kind of content around the Airflow and Databricks integration as well. Definitely look to our website on our webinars page. Like that. If you have additional questions or want to reach out to us, our website also has a contact us form that you can fill out. There were a couple of questions in the chat about consulting or additional sort of in-depth questions based on your specific use case. Please reach out to us. We'd love to hear from you. And thanks everybody for joining today. And like I said, look out for other webinars on this topic coming up, scheduled in the next couple of months. And so with that, we hope you all have a great rest of your day. And again, thanks for joining us.
Thanks all. Bye.
Everybody.